Hello everyone. In a few minutes I will look at today's Advent of Code question and show how to solve it in Lamdu. Yesterday's stream with Advent of Code number 12, actually I stumbled upon a bug in Lamdu, which is fixed now. It was actually a bug in our custom UI framework, which we have, for all of the text-like animations we have. If I turn off I don't know if you see it in the stream because maybe the frame rate is not big enough. Yeah, but we made our own UI library for this text-like UI with animations and with responsive layout. So I did solve the question after the fact, and this one special thing that I didn't do in the previous days is I used Lamdu's mutable local mutation mechanism, so similar to Haskell's stmonad. We can run a local mutation, and there's some local mutation type that actually we're not showing it. The type editing and presentation of nominal types in Lamdu needs work, but there's like a for all B over there, and this is the B here, for those familiar with the stmonad. So here we have like mutable arrays which we can create and append to, and read from and write to. Yeah, and experience isn't as nice as the purely functional part. Like when you create the array here, what is the value? It's the value for the array in the time of its creation. So let's look at today's problem. The time has come. So, per usual, I'm just going to copy the input, assuming that this is this is probably the input. So first let's copy it, and then see how we need to parse it. I'm guessing, from the looks of it, that it revolves around pairs with the two new lines between each. So if we do this, and let's call this Advent, what day are we at? 13. Example input O. I almost forgot, I need to start the keycaster so you can see what I'm clicking. Okay, so let's place it here. Great. Few people have asked for that. So yeah, now let's close the example input, and yeah, this is, we see the first block here, and let's see how we should parse that. So we're talking about pairs of packets from a distress signal. But the packets are out of order and we need to reorder them. Or actually identify how many of them are in the right order. So we need to compare. Okay, so it's always pairs. So let's start with that actually. So we'll map it and we'll split on the lines, and yeah, let's turn it into an array, and then we'll have pairs which have a certain structure to them. Let's figure it out. So ideally, I would parse it into a recursive data structure, which would require defining a nominal data structure, which we don't have the UI for in Lamdu yet. It's one of our long-standing issues. So, yeah, that's another embarrassment point for Lamdu here. I'll just, so they are called left and right, let's just keep them as strings. So left would be the first one, and we'll try to process them in place. So we have this, and what do we need to do with them in the end? In the end, we are summing indices of these. Yeah, so let's zip this list with the indices that start with 1. Yeah, so iterate from 1 and with an empty tail, then depending on some condition, we either sum the index or don't. And the index is the right hand side, and then we sum everything. So I'm marking everything and clicking sum and choosing it. And tab goes to the hole I need to fill in here. And that's what I need to, oh, let me move my face out of the way here. It's also kind of big, taking a lot of place in the screen. If you have any questions, if you're watching this live, yeah, haven't had a lot of participation in live comments, but had some. Then feel free to ask anything. It should appear in my chat window in OBS Studio. So, what is the rule? One thing I know is we should handle brackets in a certain way. So what are they saying? What are the conditions? If both values are integers, okay. If both values are lists, or if one is. Then at the end, we can basically we have a function returning true or false here. So let's make a new function and call it advent13 check, and it gets left and right. And yeah, let's start with something. Let's start with returning true for a sec. Do a false implementation, and I'm just going to call advent13 check with left, and with tab right. Yeah, that's a downside of sugar applying in the middle of your typing, but I still think that syntax sugar is definitely worth it. Yeah, I'm talking about giving the left for variable to the left parameter just shows like this with this funny symbol. So now let's do this. So let's read the rules. Both values are integers. The lower should come first. Continue checking to the next part of the input. Both are lists. Okay, so I'm going to let's make like an is list of x. It would be x dot text dot byte at. I guess we should make bytes just an array of byte type, but we don't. Yeah, well, we currently compile to JavaScript, so but when we do compile, we should make a packed array of byte type. We should have type classes first, though. If that is equals, or let's do the other way around. From code point of this equals this character, then it's a list. Now, if is list left and is list right, then it's one thing. Let's make it true for a sec. Oh, so look, why is the red line here? Because before it didn't know the type was text, and this is considered changing the type for admin 13 checks that require manual approval. I guess if the type fits, maybe we should make it let you run it, but still have like not a red underline, maybe a yellow one. Okay, so I'm approving these are the types, and so the case we have is both our lists. So let's handle that, and let's make false in the other case that we didn't handle yet. So now we can close this for now. Focus on this function, and oh, you know what? As they closed it and they closed the repo we had, let's first give it a name. Advent. Sorry. Go here, Advent 13. And now I can close it and I can recall it later. But now I'll make a repo which calls Advent 13 check with like, yeah, let's do 5 and 6. Simple examples. So if these are lists, we should break them into parts. Now, it's not a simple manner of just breaking at commas, because there could be nested lists, right? So we're actually having like nested I guess let's see. So first, let's have like a trim of, yeah, of it. It would be like x dot text dot slice from 1 to length of bytes. Yeah, -1, and we'll turn it back to text again. So first of all, we can do here, we have trim of left, right? That's 5, that's fine. And we don't want to just separate. Why is this? Oh, reach the hole, right? Now I want to break it, not just break it on commas. Yeah. So I guess let's make another function, and let's call it break it commas, or let's call it advent13 break. Advent13 break, and it would take a string. And for example, let's start with the first wrong implementation, which is breaking at commas. Actually, now let's use it. Advent13 break with like 5, 6, 7, and then turn it into an array, right? But what if it's like 6, 8? No, that's not what we want to do, right? Because we want the inner brackets to be separate. So what will we do? I guess let's take the characters of X and fold over them. And then whatever character we are facing, so whenever we face a bracket, we want to increase or decrease a count. Yeah, I guess I'm not going to do it the most efficient way, because we're going to separate into words, but then go over it again when separating the inner lists. Then I wonder what the second stage would be, or the input would my quadratic complexity be my demise? I guess in our case, actually, if one list is over, well, let's finish what we started though, right? It might be easier to make it actually as iterating over bytes of the text and using indices and slices. I'll show you what I mean. So yeah, x0 dot text. Now it becomes text in bytes now that it knows what the types are. That's fine. And let's iterate over 0 to length of bytes. And let's fold over that. And and let's have a current, which is bytes at this index. And actually, let's make it into a character. And And let's make state like this: start equals 0 and depth equals 0, right? And what I'm going to do is, if the character equals open square parentheses, then we're going to continue with the same start, but the current depth plus 1. And if the character equals the closing parens, I will continue with the same start and depth minus 1. Right. Then, if character equals a comma and the depth equals 0, then, okay, so you may have seen the layout changed. So the layout was automatic and it fit before horizontally. And also the branches of the if, elif all aligned. The moment I chosen depth equals here, there's not enough room to fit it in the screen like this, so change the layout. Layout is automatic and responsive. If I change the size of the window, if I would open it in Lamdu in a smartphone, which we don't have a version for yet, but in the future, then it should be responsive. Okay, and depth equals 0. In this case, we're breaking. So, yeah, so we'll output an item, which would be a text of a slice of the bytes, yeah, of these bytes at starting at start and stopping at the current item. And then we will continue with the next position as the start of the next thing, and depth equals 0, right? No, because you don't see the code. Okay, so otherwise we're just going to continue with the same start and depth. I can just yeah, accumulator in this case. Yeah, that's what I want to say. Accumulator, if you see here, it has the start and depth. And yeah, actually we can see what's going on here. Oh, there's an error, reach the hole, because I didn't finish here what happens in the end. But we already see, can already see that it started, and yeah. So the first character was 5, and then comma, and we see what branch happened, and then it was this, and then the depth was 1 more. I'm pressing Alt up and down to change the invocation scopes of this lambda. And then at the end, there's a start, there's a depth, and yeah, we just need to give 1 more item, and the item would be text of bytes dot slice at from this start to, you know, to the length of bytes of these bytes. And yeah, now we see the result is this. So we have this Advent 13 break thing. What I want to do before I wanted to compare Advent 13 check, and let's make up some examples. 5 here and 6 here, and we reach the hole here. So we want to, yeah, we don't want just to trim the text. Well, we want to trim it, and we want to break it. Let's not call it trim, let's call it parts. So this we're gonna give to Advent 13 break, and we have the parts of the left. Yeah, and we have parts. And then what do we do with those? We zip them with the parts of the right. That's right. So let's zip the parts of the left with the parts of the right. And what do we do when they're both numbers like this? What is the rule? If both are integers, the lowest comes first. Okay, and so we don't just want to zip, we actually want to okay, let's do this. If LHS is smaller than RHS, then the left is first, which is correct. So we say this is right. Right order. Right? Okay. And if LHS is bigger than RHS, this is wrong. Otherwise is sorry, I'm doing it wrong. I'm doing it wrong. I should check using recursively Advent 13 check. That's what I should do. Advent 13 check. No, Advent 13 check. Yeah. And actually, if we, instead of calling them left and right, let's call them LHS and RHS. Then we could use the syntax sugar for the same LHS and RHS of zip, which work naturally here. Now this has the wrong types. Yeah, it has this record here. Let's use these names. Yeah. So yeah, so we call it recursively, and actually I don't want to return a Boolean, so let's change it. Yeah, make it run. So now what happens in the case of the tails? If the left is longer, then this is right. This is right. And what is the problem here? Oh, zip, I should return a list. Yeah, so I'm returning a list of comparisons. So okay, so let's explain the tail here. It says there's a remainder in LHS or in RHS, but it actually could be empty. So in case if it's empty, it's nothing. So I'm going to map it so that for every item in the remainder, meaning the right is longer, then I'm going to return right. And if there's any item in this case, list2 dot map, then it's wrong that the first list is longer. Yes. So we have these, and I wanna fold over those. And the initial would be resume. Well, no, sorry. There is no initial value. And what we do here is we match an item, and either case here is actually we're adding another case, which is tie. And in the case of tie, I'm going to continue. Sorry, I need to add a lambda here. That's something we need to change. When I add a case, it should add a lambda for me. I will collect all these cases. So then I need to continue. And actually, continue would be my whole function. Okay, in other cases, let me make it an open case and remove the right and no, actually. So if it's wrong, then the whole answer is wrong. If it's right, then the whole answer is right. Otherwise, we continue. Then what do we do at the end? So we are, I guess, we can conclude with a tie. No, sorry. As you see, I'm not the most, yeah. Let's remove these cases. Oops, what happened? Okay, just face the bug where the cursor didn't come to the right place after removing a field. Any other case, we finish at this point and return the item as is, right? And that's also what we do at the end. At the end we return a tie. That's what we do at the end. That's great. So we can return right, wrong, or tie, which means it's not the wrong order, it's the same order. And like, neither could come first. They are identical, I suppose. And yeah, this would be just what we return. So in this case, I need to so they are not both lists. So if one is a list and the other is not, let's first handle the case they are both neither. So not is list LHS, sorry. Let's close. We have an interesting rule about where parentheses go, which is different than Haskell, by the way. Not is list RHS, so they should both be integers. So let's parse them. Parse LHS and why are we not running? Reach the whole. Oh yeah. But why don't we get the parsing of LHS? Parse RHS. So if num0, I'm not in the, sorry, if I want to see it, I need to browse to the scope. So Alt down, yeah. So this scope went to, it recursed and it's comparing 5 and 6. So if num0 smaller than num1, then we are right. Okay, so I went to the hole, I just pressed entered, and because it knows it should be this sum type, it gives me the options. So it's right. If num0 is bigger than num1, then it's wrong. Otherwise, it's a tie. Right. So then, one is a list, but the other is not. So if, I guess, is list LHS, then we will recursively advent13 check of the same LHS, but RHS would be a concatenation of this. Sorry, concatenation of this plus RHS plus closer. Otherwise, we'll be doing the other way around. LHS and RHS. So we should have the check for the different cases. So let's see, 5 and 6. Okay, what if it's 7 and 6? Wrong. If it's 6 and 6, tie. 6 and 5. Right. So this, the left one, was supposed to be shorter. So let's see. Let's see. We zipped over them. We had a tail with LHS. This should be wrong. This should be right. Okay, let's close it. Wrong. Yeah. Right. Tie. Okay. Let's make a list in the list. Tie. Okay. Let's make this longer. Yeah. Okay. So let's go back to. Let's close this and go back to advent 13. And instead of this, I'm going to do advent 13 check of left and right. I'm going to pattern match over it. What do we do with ties? I don't know. So let's say only wrongs are zeros, and let's make actually all other cases, return the index RHS, right? And now we just delete this, yeah. And we sum them, right? And we get an error. Why? Can we? Ooh. Oh man, we have a bug in, I guess, how we transpile into JavaScript. I'm getting more and more bugs, and I can't. So let's see. Let's go back. I don't know. And right, the first one, and they get the same error. We have to go deep to see where this error comes from. So Alt down, I iterate, and I see this finishes, this finishes, this finishes, this finishes. And this one with the empty list does not. Okay, so even though we had, it's not a helpful error. You can see which case It's not being handled. Yeah, this Advent 13 break doesn't know how to handle empty lists. I guess it returns an empty string in the parse is, so there are empty lists as well. So I guess we just need to augment Advent 13 break so that in the specific case where we finished and finished just as we began, let's do Advent 13 break of the empty text. Yeah, it shouldn't do that actually. So in this case, let's do this. If the length of bytes equals 0, then we want an empty list. Otherwise, we want this list. And now this is empty, but now it has stuff. Fine. So yeah, let's remove this one and go back to Advent 13. And we get a result being 13 this time. And the answer should be 13. Yeah? So let's get my puzzle input. All right. Oh, let's make this into a function, proper function. So input, and now we can call it from here, Advent 13 with Advent 13 example input gives 13, but with Advent 13 my input, paste, close. Ooh, why is it not closing? Okay, 5196. Let's see. 5196. Submit. Yes. Part 2. Okay. We'll make it in time for you to see the soccer game if you're following that. World Championship. Okay, now we have a different. Do we have a different input? No. Oh, we need to output. Okay, we need to parse the input differently. So let's do this. Part 2, and yeah. Let's give it the example input, and first with part 2 being false, right? Now we're gonna use true, and we want it to work differently. Let's remove the annotations. Actually, I don't know if there's anything in common with part 1 and part 2. So in this case, like we broke apart the common functions. So let's just call this, yeah, let's just call it Advent 13 part 1. Sorry, I changed the name object. Not sure what's the best recommendation. And do a whole different new thing, but we will use the same. So Advent 13 example input, and now I will split it at lines, I suppose, and we will filter out the empty lines. So text isn't the empty line, and we organize them into the correct order. Find the decoder key. Okay, what is a divider packet? It's always these, I guess. And we need to find where they are in the order. So let's sort it now. And we are going to use the Advent 13 check of LHS and RHS. And we are going to pattern match on it. So, yeah, so this case is true, but the others are false because we're implementing a smaller than operator here. And yeah, we have it sorted. Is it? Yeah, we have it sorted according to the order. That's cool. Yeah, it matches. And we want to find the indices of these two and multiply them. Okay, so let's, as usual, zip it with 10. I guess that we're starting at 1. So let's do iterate 1 and num plus 1. And when we're done, no more items. Oh, this is an array and we need to do from array to zip it, which turns it into like an iterable. In the end, we're having no more items for this list. And what I'm going to do is, like, I'm going to collect a product of everything, which is well, you know what? Let's use filter. So I'm just going to zip it with ID. So I have pairs. And I'm not gonna do product yet. I'm going to filter over them. Then I'm going to map over them, dot map. And sorry, what did I map? I mapped the number. It's a bit less responsive. So I mark all of this, and I want to map over it. I press open parentheses, dot map. So it applies over here. And I'm just going to take, does it know the type of X? Yeah, so I'm going to accept the type here, remove this, okay, and I'm just going to take the RHS, which was the index. And here I'm going to do LHS equals one of these packets. So 2 close, or was the LHS never this? It's strange. Let's collect this for a sec into a let item. Let's check what is array at where they're saying 2 is. It's like at index 10, which is should be 9, 0 based. This is 3. Okay. So 8, 10. Does the example input even have these? No. Oh, they're not here. Oh, they're not in the example input? Oh, we should add them. Okay. We should always add them. Okay. so before sorting, yeah, let's add the two packets, the two special packets. Yeah, let's make a list of the special packets actually. Let's concatenate the lists here, and put this list here. Let's turn off the annotations. You would usually edit code like this, I think. I haven't really used Lamdu in Angular so much. And I want to create this, sorry. Okay, I want to make a let item above or, yeah. And I want to use it here. And this would be like, how do they call them? Dividers. Dividers, right. So dividers, these are the divisors. Empty. Okay, and 6. These are the dividers. And in this case, I want to like do member. Do I have member? Okay, no. I will do dividers dot any of text2 equals the LHS. Yeah, this should be it. I don't need that. Well, I can look at them. Let's see. Let's do the values again. Okay, so it's position 9. Now we have 2. Okay, we don't need this anymore. And actually, let's make it concise again. Yeah, let's put this here. Yeah, now let's call this. Yeah, let's call it Advent 13 Part 2. Let's get an input and input here. Let's close it. Let's call Advent 13 Part 2 with Advent 13 example input. 140. Is that the answer? Yes. Okay. So Advent 13 my input. Takes it a bit more time. 22134. 22134. Submit. All right. So that was today's Advent of Code. What is the drawing becoming? I don't know. Yeah, so what did we see? We see that we don't have nominal type editing. Otherwise, I would have parsed the arrays into a data structure to begin with. Actually, I made this diagram of things that Lamdu misses to be really awesome. And we just saw that like we could do without it. For example, you could program it. I think Elm doesn't have type classes, but people program in it. Sure, so I can still program stuff in Lamdu, but perhaps I would like to do things differently. So I would have liked to use a nominal data type, which is this red thing over here. Yeah, we need to add nominal type editing. We just hadn't gotten into it yet. We're still actually optimizing the term editing. Yeah, I will collect personal feedback from my streams and change some stuff. So hopefully the next release of Lamdu would be even nicer. Yeah, so what we see here, all the red stuff that's missing actually are missing for Lamdu to being really useful for stuff like, well, for production stuff, for research like machine learning, or for front-end development, or for teaching programming. For teaching programming, we just need a graphics library, because to make drawings with Lamdu, because that would be something that both students and kids would like. So I guess this is the closest purple goal here. Yeah. So anyhow, this has been this has been today's cast. See you next time. Bye.